Welcome to our exploration of centripetal and centrifugal forces. These two concepts are fundamental in understanding motion, especially when objects move in a circular path. Whether you're watching a car take a sharp turn or spinning a bucket of water, these forces are at play. Today we'll break down what each force means, how they differ, and where you can observe them in everyday life. Let's start by setting the stage with a quick overview of what forces are and why they matter in physics. Forces are pushes or pulls that can change the motion of an object. Now let's dive deeper into the world of circular motion. Circular motion occurs when an object moves along a curved path or a circle. Think of a satellite orbiting Earth or a child on a merry-go-round. In these situations, the object is constantly changing direction, which means there must be a force acting on it to keep it moving in a circle. This is where centripetal and centrifugal forces come into play. Understanding circular motion helps us grasp why these forces are necessary and how they affect the movement of objects in our daily lives. Centripetal force is the force that keeps an object moving in a circular path. The word centripetal means center-seeking. This force always acts toward the center of the circle, pulling the object inward. For example, when you swing a ball on a string, the tension in the string provides the centripetal force that keeps the ball moving in a circle. Without this force, the object would fly off in a straight line due to inertia. Centrifugal force is often described as the force that seems to push an object outward when it is moving in a circle. The word centrifugal means center fleeing. However, it's important to note that centrifugal force is not a real force in the traditional sense. It's what we call a fictitious or apparent force that we feel when we are in a rotating reference frame. For example, when you take a sharp turn in a car, you feel pushed outward, but this sensation is due to your body's inertia resisting the change in direction. Inertia is the tendency of an object to resist changes in its motion. When an object moves in a circle, its inertia wants to keep it moving in a straight line. The centripetal force counters this inertia, pulling the object toward the center. The sensation of being pushed outward, which we call centrifugal force, is actually your body's inertia at work. Understanding inertia helps clarify why these forces are experienced during circular motion. Imagine you're in a car taking a sharp turn. As the car turns, you feel like you're being pushed against the door. This is a classic example of centrifugal force in action. In reality, the car's tires provide the centripetal force needed to change direction, while your body's inertia makes you feel as if you're being pushed outward. This example helps illustrate how both forces are experienced in everyday situations. When you swing a ball attached to a string, the tension in the string acts as the centripetal force, pulling the ball toward the center of the circle. If the string breaks, the ball flies off in a straight line, demonstrating inertia. The feeling of the ball pulling outward on your hand is the apparent centrifugal force, but it's really just the ball's inertia resisting the inward pull. On a merry-go-round, you feel like you're being pushed outward as it spins faster. The platform provides the centripetal force, keeping you moving in a circle. If you let go, your body's inertia would carry you off in a straight line. This is another clear example of how centripetal and centrifugal forces are felt in everyday life, especially during play and amusement rides. During the spin cycle of a washing machine, clothes are pressed against the drum's wall. The drum provides the centripetal force, keeping the clothes moving in a circle. The water, not attached to the drum, is flung outward and removed through holes, thanks to inertia. This process uses the principles of centripetal and centrifugal forces to clean your clothes efficiently. Any amusement park rides, like spinning swings or roller coasters, rely on centripetal force to keep riders moving in a circle. Riders often feel as if they are being pushed outward, but it's actually their inertia at work. The ride structure provides the necessary centripetal force, ensuring safety and excitement. Understanding these forces helps explain the thrilling sensations we experience on such rides. Satellites orbiting Earth are constantly falling toward the planet due to gravity, which acts as the centripetal force. However, their forward motion keeps them in orbit, creating a balance between gravity and inertia. This delicate balance allows satellites to circle Earth without crashing or flying off into space, demonstrating the importance of centripetal force in space technology. Planets orbiting the Sun are another example of centripetal force in action. The Sun's gravity pulls the planets toward it while their inertia keeps them moving forward. This combination results in stable elliptical orbits. Without centripetal force, planets would drift away into space, and without inertia, they would fall into the Sun. Sports like hammer throw or discus rely on centripetal force. Athletes spin the object around before releasing it. The tension in their arms or the wire provides the centripetal force, keeping the object moving in a circle. When released, the object flies off tangentially, showing the effect of inertia and the absence of centripetal force. You might experience centrifugal force when stirring a cup of coffee. As you swirl the liquid, the coffee seems to move outward, away from the center. This is your frame of reference experiencing the apparent force, while the actual force keeping the coffee in motion is centripetal, provided by the cup's walls. Engineers use centripetal force in the design of curved roads and racetracks. The banking of the road helps provide the necessary force to keep vehicles safely on their path. Without enough centripetal force, vehicles could skid outward, especially at high speeds. This application shows how understanding these forces is crucial for safety. Industrial machines like centrifuges use centrifugal force to separate substances of different densities. As the machine spins rapidly, heavier materials move outward while lighter materials stay closer to the center. This process is essential in laboratories and industries for separating liquids and solids efficiently. Roller coasters are designed with loops and curves that rely on centripetal force to keep the cars safely on the track. As the coaster speeds through a loop, the track provides the inward force needed to maintain circular motion. Riders feel pressed into their seats, experiencing the effects of both centripetal and centrifugal forces. Clothes dryers use centrifugal force to help remove water from clothes. As the drum spins, water is forced outward through the holes while the clothes are pressed against the drum's wall. This process speeds up drying and is another practical application of centrifugal force in household appliances. Athletes running on curved tracks experience centripetal force as they round the bend. The friction between their shoes and the track provides the necessary inward force to keep them on course. Without enough friction, they would slide outward, demonstrating the importance of centripetal force in sports. Salad spinners use centrifugal force to dry greens. As you spin the basket, water droplets are flung outward through the holes, leaving the leaves dry. This simple kitchen tool is a great example of how centrifugal force can be harnessed for practical purposes. Cyclists turning a corner must lean into the turn to balance the centripetal force needed to stay on the curved path. The friction between the tires and the road provides this force. If the cyclist goes too fast or the road is slippery, they risk sliding outward, showing the delicate balance involved. Playground equipment like spinning carousels let children experience centrifugal force firsthand. As the carousel spins, kids feel pushed outward, but the bars provide the centripetal force needed to keep them safely on the ride. This playful example helps children understand the forces at work. Some space station designs use rotation to create artificial gravity. The spinning motion provides centripetal force, pressing astronauts against the outer wall, simulating gravity. This innovative use of centripetal force could make long-term space travel more comfortable for humans. Paint mixers use centrifugal force to blend colors evenly. As the container spins, paint is forced outward, mixing thoroughly. This process ensures a consistent color and texture, showing how centrifugal force is used in manufacturing and art. Some animals, like dogs chasing their tails, demonstrate centripetal force in action. As the animal runs in circles, its muscles provide the inward force needed to maintain the circular path. This playful behavior is a natural example of physics at work in the animal kingdom. Spinning amusement rides like the Gravitron use centrifugal force to press riders against the wall. As the ride spins faster, the apparent force increases, making it difficult to move. The ride's structure provides the centripetal force, keeping everyone safely inside. Water slides with sharp turns use centripetal force to keep riders on the slide. The slide's walls provide the necessary inward force, allowing for thrilling curves and safe rides. Without enough centripetal force, riders could lose contact with the slide, emphasizing the importance of design. Industrial separators use centrifugal force to sort materials by density. As the machine spins, heavier particles move outward while lighter ones stay closer to the center. This technology is vital in mining, food processing, and recycling industries. Figure skaters use centripetal force to spin gracefully on the ice. The friction between their skates and the ice provides the inward force needed for tight spins and turns. Mastery of these forces allows skaters to perform complex routines with elegance and control. Spinning toys like tops and fidget spinners demonstrate centrifugal force. As the toy spins, parts of it are pulled outward, maintaining balance and stability. This simple example helps children visualize the effects of spinning motion and the forces involved. Dancers performing spins and pirouettes rely on centripetal force to stay balanced. The friction between their feet and the floor provides the inward force needed for smooth, controlled turns. This artistic application of physics adds grace and beauty to dance performances. If you fill a bucket with water and spin it in a circle, the water stays inside even when upside down. The bucket provides the centripetal force while the water's inertia creates the sensation of centrifugal force, keeping it pressed against the bottom. Spacecraft use centripetal force to maneuver around planets and moons. By adjusting their speed and trajectory, they can enter stable orbits using gravity as the inward force. This technique is essential for successful space missions and satellite deployment. Oil extraction processes often use centrifugal force to separate oil from water and other impurities. As the mixture spins, denser materials move outward, allowing for efficient separation and purification. This method is widely used in the energy industry. Astronomers study centripetal force to understand the motion of stars and galaxies. Gravity acts as the centripetal force, keeping celestial bodies in orbit. This knowledge helps scientists predict cosmic events and the structure of the universe. Medical labs use centrifuges to separate blood components. As the machine spins, heavier cells move outward while plasma stays near the center. This process is vital for accurate blood tests and medical diagnoses. Engineers consider centripetal force when designing rotating machinery, such as turbines and engines. The materials and structure must withstand the inward force to ensure safe and efficient operation. This careful planning is crucial for reliability and performance. Dairy processing plants use centrifugal force to separate cream from milk. As the milk spins in a separator, the lighter cream collects near the center while heavier milk moves outward. This efficient process is essential for producing cream and skim milk. Gymnasts performing on rings or bars use centripetal force to execute spins and flips. Their grip and muscle strength provide the inward force needed for controlled motion. Mastery of these forces allows gymnasts to perform impressive routines safely. Gold mining operations use centrifugal force to separate gold from other materials. As the mixture spins, heavier gold particles move outward, making it easier to collect. This method increases efficiency and recovery rates in mining. Automotive engineers design vehicles to handle curves safely by maximizing centripetal force. Features like tire tread, suspension, and weight distribution all play a role in providing the necessary inward force for stable turns. This attention to detail enhances safety and performance. Sugar production uses centrifugal force to separate sugar crystals from syrup. As the mixture spins in a centrifuge, crystals move outward and are collected while the syrup remains inside. This process is key to efficient sugar refining. Track racers, whether on foot or in vehicles, rely on centripetal force to navigate curves at high speeds. The track's design and surface provide the necessary inward force, allowing for fast, controlled turns. This principle is essential for competitive racing. Pilots experience centrifugal force during sharp turns and loops. The aircraft's structure provides the centripetal force needed to change direction, while pilots feel the apparent outward force. Understanding these forces is crucial for safe and precise flying. Wrap up: centripetal and centrifugal forces are essential concepts for understanding motion in a circle. Centripetal force is the real inward force that keeps objects moving along a curved path, while centrifugal force is the apparent outward force we feel due to inertia. From amusement rides to engineering and nature, these forces shape our world in countless ways. By recognizing their roles, we gain a deeper appreciation for the physics behind everyday experiences and advanced technology.